Question 3. Prove by contradiction that there is no greatest odd integer. To prove by contradiction, we have to find a statement that is totally opposite to this one. So the original statement said there is no greatest odd integer. So our new assumption will be there is the greatest odd integer. So we are going to prove this statement instead. First, we suppose n is the greatest odd integer. If n is the greatest odd integer, that means n can be written as 2k plus 1, where k is an integer. Well, let's consider the next number, n plus 2. We know that n is 2k plus 1, so we use 2k plus 1 here, and then plus 2. We can rearrange it to be like 2k plus 2, and then plus 1. So we can factorize 2 from the first two terms like this. And you can see that this term is an odd number for sure, because you have a multiple of 2 here and then you plus 1 at the end. So it has to be an odd number. So we know that n plus 2 is also an odd number. But we know that n plus 2 is greater than n. So that means n is not the greatest odd integer. And you can see the contradiction here. In the first place, our assumption said there is the greatest odd integer, which is n, right? N is the greatest odd integer. But eventually we found another number that is also an odd number and greater than n. So that means n is not the greatest number. So you can see the contrast here. So that's the contradiction. So it means our assumption is wrong. So the original assumption is correct. So hence, there is no greatest odd integer. That's it. Here's come to problem 4. The curve C is defined by the parametric equations x and y here in terms of t, and t has to be greater than 0. Show that the equation of C can be written in the form y equals to gx, where gx is in this form, and x is greater than k. A, B, C, D, and k are integers to be found. And then we have to find the range of g. First of all, we have to change t in terms of x, because between this one and this one, t in terms of x, it would be easier. From x equals 1 over t plus 2. 1 over t will be x minus 2. So t will be 1 over x minus 2. And then we substitute t into another equation, which is an equation of y. So from y equals to 1 minus 2t over 3 plus t. So we substitute t equals to 1 over x minus 2 into this equation. So 1 minus 2 times 1 over x minus 2 divided by 3 plus 1 over x minus 2. And then we make the top part to be a single fraction and the bottom part to be the single fraction too. And then we can simplify it to be x minus 4 over 3x minus 6 plus 1, which is minus 5. So that means gx is x minus 4 divided by 3x minus 5. And next we have to find the domain of this function. So the domain of the function is x. X is originally 1 over t plus 2 when t is greater than 0. From t is greater than 0, we know that t equals 1 over x minus 2. So we substitute it here, 1 over x minus 2, which is greater than 0. That means if the reciprocal is greater than 0, itself has to be greater than 0 too. X minus 2 is greater than 0. So x is greater than 2. So the answer is gx equals to x minus 4 divided by 3x minus 5, and the domain is x is greater than 2. Next, we have to find the range of function g. We can consider the range of g from the value of y, which is 1 minus 2t divided by 3 plus t, where t is greater than 0. You can try and plug in values of t, for example, when t is 0. So if t is 0, y will be 1/3. And since t has to be greater than 0, that means we can increase the value of t to be 1. If t is 1, you can see that y will be negative 1 over 4. And then we can keep increasing the value of t. If t is 100, y will be negative 1.932. And if we increase the value of t to be 10,000, it will be negative 1.99. So as t increases, y starts from 1/3, but it will never reach negative 2. So negative 2 will be the lower bound for this one. And the function g, and you can see the maximum number is 1/3, which is not included either because t is not 0. So this one will be just less than 1/3. And that's the range of the function g. Here's come to problem 5. Using the substitution u equals to 3 plus square root 2x minus 1 to find the exact value of this integration. And given your answer in the form p plus q ln 2, where p, q are integers to be found. And since u equals to 3 plus 2x minus 1, we have to find du by dx. So du by dx is differentiation of 3 plus the differentiation of 2x minus 1 to the power of 1/2, which is 0 plus 1/2 times 2x minus 1 to the power of negative 1/2 and times 2 from chain rule. So du by dx will be 1 over square root 2x minus 1. That means du will be 1 over square root 2x minus 1 dx. And then we can substitute u into the integration. 113 4 over 3 plus square root 2x minus 1 dx equals to 113 4 over u dx. And we need this dx to be du. So we need 1 over square root 2x minus 1 in our integration. That means we can multiply and divide by square root 2x minus 1. So we write everything down here, and you multiply by square root 2x minus 1 and multiply by 1 over square root 2x minus 1 dx. which the whole thing is just 1. So we didn't change anything. And then 113, 4 over u square root 2x minus 1, and this term becomes du. Then we have to change 2x minus 1 to be the terms in terms of du. So how can we change that? We know that u equals to 3 plus square root 2x minus 1. That means square root 2x minus 1 is u minus 3. We can substitute this u minus 3 back into this term, which is 113 here, 4 over u times u minus 3 du. And then we simplify this term. It's going to be 113. We can factorize 4 out. So 4 is here. And this one will be u minus 3 divided by u, du here. And then we separate this fraction. So it will be 113, 1 minus 3 over u du. Now we can integrate it. So this term is 4, and here is u minus, since the integration of 1 over u du equals to ln absolute value of u. So this one will be 3 ln u. And then we have to find the new upper and lower limits of u, because this one, 1 and 13, they are upper and lower limits for x. This is x equals 1, this is x equals 13. But now we have everything in terms of u, so we have to find the values of u to substitute in. So we know that u equals to 3 plus square root 2x minus 1. From this lower limit, x equals to 1, we can find u. We're going to substitute x equals 1 into here to find u. So u will be 3 plus square root 1, which is 4. And for the upper limit, x equals 13, we do the same thing. And then u will be 8. And these are the new upper and lower limits. So we put it back here. This is u equals 8. This is u equals 4. And then we can substitute the upper and lower limit back in here, which is 4 times 8 minus 3 ln 8 minus 4 plus 3 ln 4. And then we simplify the terms inside the brackets. It will be 4 plus 3 times ln 4 minus ln 8, which is 4 times 4 plus 3 ln 4 over 8. Then we can expand 4 inside the brackets, so it will be 16 plus 12, and this one will be ln of 1/2, which is 16 plus 12 ln 2 to the power of -1. 16 minus 12 ln 2, and that's the answer.